We are going to explore some mapping techniques for representing quantitative data in ArcGIS. And we're going to start with the mapping technique that we learned about in the intro class, but we're going to go in a little bit more detail about what we are looking at. The first type of map we're going to learn how to make is a choropleth map, also known as a graduated color map. If you remember from the intro class, the way we would create a graduated color map is by going to our layer properties, our symbology tab, then quantities, and then selecting the field in which we want to make the map based off of. In this case, is we're going to be looking at total population. Once you select that field, you can then make some changes here. But before we start making some changes, just to let you know what's happening here so that you understand. So in terms of population in Lebanon County townships, the population runs from 0, and the highest number of people in any given township is the 25,661. So that's your data range. If we click on the classify button, you can see where most of the values reside, and you can see that there's probably just one township that has a high number, but most of them are in these lower categories. So we're going to see one pop out above all the others. And when we look at our classification statistics, they'll tell us how many townships there are, 26, what the minimum population in any of the townships is, what the maximum is, what the sum of the population is, the mean, median, and standard deviation. So some really cool little stats there. And if you remember from the intro, we learned how to change these break values so that they make a little bit more sense. But we didn't really get into too much are the various classification techniques. And we're going to just kind of explore what the data looks like with each of these classification techniques. And for right now, I'm not going to change these break values, but I am going to get rid of those zeros to make things a little bit easier for us to read. And I'll also add commas, again, just to make it easier to read. So now when I symbolize this using a natural breaks algorithm, and what a natural breaks algorithm does is it finds natural breaks in the data and then groups those ones that are kind of similar together. So when I hit the OK button, I get this as the result, and I'm going to label the townships just so we know which one is which as we are working through this. And we can see Lebanon is the one, as probably expected, that has the highest population. So that was using the natural breaks algorithm. Now going back to that classification histogram, you can see that a lot of the values are kind of clustered at one end. And that's why what natural breaks is so good for is that it really works with data that is just awkwardly spaced. We have other classification techniques that we can use. We can use equal interval, where the interval is always going to be the same. So the interval is between classes is 5,132. A lot of people like this classification scheme because it's easy to understand, but what happens is, notice like this class here has no townships in it, so it makes for some classes that are completely empty, which sometimes isn't the best. So the equal interval classification scheme is best used when your data is distributed along the number line. It's not clustered like it is here, but let's take a look at what happens when we do this. And you can see that, there's a couple that really stick out, like again, Lebanon, and you can see there's a whole lot that are really on the low end of this. So that's the equal interval. Now quantile will put the same number of observations in each class. So if there's 26 townships and we divide that by 5 classes, it essentially is going to put 5 townships in each class, with one class having 6. So if I hit OK for this, again, we're going to see a little bit of a different map. And so there we have it. So that is using the quantile option. And again, quantile is best when your values are distributed like equally along the number line, that they're not clustered at one end. So I would argue for the map that we're making here, we shouldn't select equal interval or quantile. And then the last one I'm going to mention is the standard deviation. And you're going to notice that the legend with this is going to look a little bit different than what we are looking at here. With a graduated color map, you know, we symbolize things with the light color that's has a little bit of something in it, and a dark color with a lot. You're going to see the standard deviation switches to a diversion color scheme. So when I hit OK, it does that. So like this is like normal, and as you move away from that, the more not normal it is. So when I hit apply there, it basically has Lebanon kind of sticking out as the anomaly on the high end. So you can kind of, you know, see how far away from normal townships are. And if you hit the classify, you can see again the histogram. And again, this is the best used when your data has that normal curve. If you remember from your statistics class, the normal curve, if your data is kind of along that line, this works really well for it. Again, this is kind of clustered at the end, so maybe not the best choice. So those are like the most common ones used. I would argue for this one, we use the natural breaks. I would use the natural breaks and then manually change the break values to make them nice and even. So that's just a little bit of an overview of our options that we have in terms of classifying our data. And I'm trying to get natural breaks here. There we go. And again, I'm going to add those commas, get rid of all those zeros. And there we have a graduated color map. So that's a little bit about choropleth mapping. One last thing that I want to talk about that we haven't really hit upon yet is the idea of data normalization. It's really hard to compare these townships with one another because the sizes are so different. So, you know, having a population, like let's say Annville had a population of 12,000 and Bethel had a population of 12,000. Their sizes are so different that that is a little bit misleading in terms of, you know, the density of the population. So something that you might want to consider doing is normalizing the data by, you know, either, you know, by like a square mileage kind of thing, or by the percent of the total population in Lebanon County. So if we wanted to do it by percent of total, we just go to our normalization, which is right under the field that we select, and click that, and then you can see what that does. And it really doesn't do anything for our map. It makes it essentially kind of the same. If we have a square mileage in here, I'm not sure if we do or not. We do not. And we can easily calculate a square mileage by using our calculate geometry tool. But that would then tell us the population per square mile, which would be probably a little bit more telling than what we're looking at here. So I'm gonna just quickly add that field so we can kind of take a look if it substantially changes the map. And I'm going to make that double. And if you remember from the previous course, to calculate the geometry, we just simply go to that tool, calculate area in square miles, and there we have it. And now if we go and normalize this by that square miles, this is going to tell us how many people there are per square mile. Again, hopefully this will yield a very different result. So you really see which areas are the more densely populated areas. The ones that are in the light color are the not so densely populated areas. And this makes a lot of sense because the towns are the ones that tend to pop out here. But again, if you want to compare apples to apples, normalization is a good idea. Otherwise, it's apples to oranges, and it's not maybe not the best comparison. So that's a little bit about graduated color maps. And one last thing, I know I've said it before, but notice the color scheme used. It goes from a light color to a dark color. I cannot stress this enough. Your color scheme should match that format. If you just use just pretty colors you like and without any regard for the conventions, you can really mess people up in their interpretation of the map, because intuitively we think of a light color as having a little, a darker color having a lot. So just by picking something that's intuitive to somebody to interpret is a good thing. If you just pick random colors just because you like them, or you may not like with the graduated color schemes, you're going to be potentially misleading individuals on the interpretation of your map. So that's graduated color. The next one we're going to talk about is proportional symbols. And essentially what this does is it places a symbol in each of the townships proportional to the size of its population. So we can select population, and down here we have to make a few selections. We have to tell it what background color we want the count or the townships to be in. I'm going to pick a nice gray, and then we have to pick a color for our dot. I kind of like that because I think that will pop off the gray nice, so I'm going to keep that. And then you have to select how many symbols you want in your legend. I'm going to pick 4, and I might change that up in a second. But then I hit apply, and notice what it does. It will put a symbol in the township proportional to its size. So you can see that, you know, again, Lebanon obviously has the most. And you might think that some of these might be hard to tell from one another. That's when you might want to switch to 3 so that the symbols are a little bit more apparent. What's really cool about proportional symbol, I'm going to show you how to create your own thematic symbols in a few lessons, or I have already shown you how to create thematic symbols. You can create your own symbol here for whatever it is that you're representing. So perhaps, like this is a population map, you want to like have a little person, you could create a little person as your symbol, and then that person will be larger the more the population is. So this is where those thematic symbols can be really kind of cool little effects for your map. And then the last one that I'm going to talk about is dot density. A dot density map is essentially where one dot is equal to some amount. And when we select dot density, we have to tell it what field that we want to make the map of. We have to change the symbol to what we want the symbol to color to be. And then we have to select the dot size. Like right now, this is a size 2 dot. And this is something I play around with as I go through, because you don't always know the answer right away. I'm going to keep that, and each dot is equal to 40 people. And again, you can change this if you want to kind of round that off to 50. You can obviously do that. You can change your background. I'm going to, again, select that light gray that I like so much, and then I'm going to hit apply, and notice you have a dot density map. Now, a couple of things with this that really have to be put out there. The first is the dot placement in a dot density map is random. Just because there's a dot here doesn't mean that there's any population there. Essentially what ArcGIS does, it takes the polygon, it figures out how many dots need to be in there, and then it just randomly tosses them in there. So there's no, don't think of this as this is where population is clustered and where it's not. It's just, you know, essentially you just add up the number of dots and multiply it by the value, and then you can get the population. So random placement of dots, to put it out there. So don't think of this as, hey, yeah, there's a cluster of people up here. That's not necessarily true. The other thing that you have to be cognizant of when creating dot density maps, and this can be a little hard, is that theoretically you should be able to count up the dots and then multiply it by the dot value to get the actual value. That becomes a little tricky in the heavily populated areas, because the dots coalesce and come together, so it's hard to distinguish those dots. So that, you can change your dot size, but there's sometimes only so much you can do to change that dot size. So you have to think about, is this mapping technique appropriate for what I'm trying to do? Is it going to be misleading? And that's the cool thing about these different mapping techniques for representing quantitative data. You have choices. If a graduated color doesn't work for your situation, you can play around with proportional symbol or dot density and vice versa. So there's no one right answer for a map. Every situation is different. So while like dot density may not work in one case, it may be fantastic in another case. So again, just something to keep in mind as you are working with these various mapping techniques. Just in my experience in making maps, I've almost never use either proportional symbol or dot density. I tend to really stick with graduated color or choropleth, only because it's a mapping technique that is easy for people to understand, and you can do things with that graduated color map to make it even further easier to understand. For instance, if I was making, a map, of Lebanon County showing population by municipality, I would make the graduated color map, which I actually will just quickly do. I would make the graduated color map. I would make sure that every township is labeled, and then I would also probably do a label expression so that not only am I providing the range for each township, I can also then put in the actual value for that particular township by just adding a double label. So I'm going to go to my total population, hit OK, and now I have the best of both worlds. I have it showing what category it falls in, if it's a low or high category, and then I also can put the exact population there. And you can do the same thing with proportional symbol and dot density. It's just that it gets really busy looking on them because of all the dots. This just is a little bit more of a cleaner display. So that is a little bit about the three most common methods for mapping quantitative data.